SwayamPrabha. Digital India. Educated India.
So, the next lecture for discussion is going to be on quality control. Pretty interesting. Quality is one thing which everybody expects. I need a high quality watch, quality performance product, like I need a quality watch, a quality shirt, a quality car, a quality cell phone. But how do you define quality? Quality is a relative term. A good quality for you need not be a good quality for me, right. So, quality itself is very interesting and it is very abstract for definition. However, people have found out several ways of defining quality, but people expect this quality everywhere. So, now in this lecture we will see what is quality control. We will try to have an introduction, then we will try to see some of the process controls, statistical process control, design for experiments and sampling techniques little bit. So, quality has become one of the most important consumer decision factor in the selection among competing products and services. The quality of a product can be decided by looking forward towards the following factors related to the product. One is performance. Will the product do the intended job? So, pretty interesting. Pen, you take a pen. So, what is the function of a pen? Is to write, correct? So, now people use this pen also as a page marker. Pen with a cap is used as a page marker. So, when I do it as a page marker, many a times the pocket holding, that fellow fails, right. So, now what was your intended job to be done? Writing. Now, the clip whatever was there has failed because you had tried to push it keeping some 50 pages. Because of the thickness, it does not have a space, because the pen is intended to just sit in a pocket where the thickness is defined. To a large extent, it is defined. Okay. So, the flexibility is given only to that extent. Now, when I try to hold 50 pages, which was not the intent of this pen, now the pen has not performed. Watch. Now, that clip has failed. Now, I cannot hold my pen. When I put my pen without a clip, whenever I bend, it falls down. Now, the pen has lost its credibility because it did a job which was not intended to do. Now, is it clear? So, what is intended job and what is not intended job? Many a times the product fails because it was asked to do a non-intended job, but finally what happens? The product has failed because of that and people say the product is useless. Okay. So, keep this in mind. Performance is very important. Will the product do what is intended to do? How often the product will fail? How long will the product last? So, performance, reliability, durability is taken care. How easy it is to repair, serviceability is taken care. How good does it look? Aesthetics has been taken care. How does the product do? Features is taken care. Perceived quality, what is the reputation of the company or its product? I am trying to hold a pen which is a Parker pen. Parker has its own reputation. Because of the Parker company's reputation, I hold his product, my reputation also goes high. Perceived quality. What then last is conformance to standards. Is the product made exactly for what the designer has intended to do? So, conformance to standard, these are some of the factors which are related to the the product, wherein which the quality of the product is talked about. So, statistical methods for quality control and improvement. So, there are three major areas where people have been working on drastically, and they have included lot of math also behind it. That means to say, it is a scientific approach, statistical process control. People have come out with design for experiments, and people have also come up with acceptance sampling. For example, I buy 10,000 pieces in a lot, and before I accept, if I start checking all the 10,000 pieces and then I say yes, the lot is good, and then I will accept, it is going to be time consuming. But one logic, if you see, all the 10,000 are manufactured from the same company by a machine or by a group of machines. So, then naturally the products which are produced are going to be good. So, every time inspecting 10,000 pieces is next to impossible. So, what do I do is I random pick some 5 or 10, and then I check the status of all the 10, and if it is all good, then I accept the lot. So, that is what is acceptance sampling. And here also there are a lot of logics. If it is a vital project, all 100% has to be done. If it is a non-vital product or a part, then what they say is, they say out of this 5, if 2 fails also, it is okay, you can accept the lot. There are certain things like that. The statistical process control is a powerful collection of problem solving tool, useful in achieving process stability and improving capability through the reduction of variability. There are 7 tools which are generally used as part of SPC: histogram, check sheet, Pareto chart, cause and effect diagram, defect concentration diagram, scatter diagram, and control charts. These are the 7 tools which are always thought of as part of SPC, which is to be followed inside your factory so that you produce a quality output. The other thing is chance and assignable cause of quality variation. So, in any production process, a certain amount of inherent or natural variability will always exist. This natural variability is the cumulative effect of many small, essential, unavoidable causes. The other type of variability may occasionally present in the output of a process. So, this is called the chance. There are control charts. If you go back here, this histogram analysis is okay. Histogram analysis is, it tries to say, suppose let us put the defects, okay, and you say these are the number of defects or whatever it is, and then you say what are the different y axis can be parts. So, it can say part A, part B, part C, part D. You have a block diagram which says that how many part A's have failed in that period. So, you can write here 52nd week. In that week, how many parts of A failed, B failed, C failed, D failed. So, that is called as histogram analysis. The check sheet is, check sheet you can even go to the, you can see in airports and other places where a list of check sheet is given. People ask you to check whether this document is submitted, that document is submitted, then this, then this, then this, then this, then finally you upload. So, that is a check sheet. We give a standard procedure, you follow it. Pareto analysis is nothing but it is almost the same, but here we try to see what is the effect of these defects on the output. So, that is what we see in Pareto analysis. Cost and effect diagram is something like a fishbone diagram. We try to say these are the causes and this is the effect of it. And then the defect concentration diagram. Defect concentration diagram is, it tries to tell how many defects have happened in that period of time. That is called as defect concentration diagram. Scatter diagram is always, you try to put all the defects and try to make a cluster. So, then what you do is you try to circle out the cluster and try to figure out what made this cluster to come. So, that is what is scatter diagram, and you can talk more about the scatter diagram. Control chart is P chart, X chart, we will see all those details later. A control chart is one of the is one of the primary technique of statistical process control. This type of chart plots the average of measurements of quality characteristics in samples taken from the process versus time. Okay. So, we try to take a product, we try to take a part which is produced, and this part can be once in 50 parts or it can be once in half an hour. So, we pull out and then try to check the various dimensions and deviations and note it down. The control chart is very useful process monitoring technique, because at every 50 or every 100 you try to pull out, measure the features, report those features and then do it. Whenever usual sources of variability are present, sample average will plot outside the control points. So, you can see that it is called as upper control limit, lower control limit. So, this is what is the mean, and here is the deviation whatever you have. It can be in diameter or something, and x can be time or number of parts or whatever it is. Now, if you look at the diagram, it is very clear there is a variation which is happening at regular intervals of time. So, whenever it tries to go very close to the upper critical limit or to the lower critical limit very close, we try to reset. For example, we try to resharpen, we try to relook into the fixture, we try to change the tool. So, all those things happen, and once it is done, so you can see that it pulls back and it goes into the normal way. So, this tries to give me a lead that yes, the time has come to reset your process. So, basic principle I have already explained to you. So, it talks about the chart containing a central line that represents the average value of the quality characteristics corresponding to in control states. So, you have an upper control, you have an in the lower control, the deviation has to fall in that only. So, the upper control limit is nothing but sigma u, so that is the mean. W is the sample statistics that measures some quality characteristics of interest, and suppose the mean of W is mu W, and the standard deviation is given as sigma W, and then this is the standard line. L stands for the distance of the control limits from the center line. The statistical basis for of the control chart. The control chart is a device that describes in a precise manner exactly what is meant by statistical control. As such, it may be used in a variety of ways. In many applications, it can be used online, and many a times it can be also used offline. So, input, here is a process can be reading, process can be cooking, process can be machining, process can be assembly. So, input, process, you get an output. So, you try to measure. So, when you try to measure, you try to detect assignable cause, then you identify the root cause for the problem. This is done by the Ishikawa diagram, and then you try to correct it, implement the correction whatever it is, and now verify once again whether the defects are coming or not. If it is not coming, it is fine. If it is coming, then once again go into this root and then you try to modify it. So, this is called as assignable cause. Okay. So, then the statistical basis for control chart is, it is very important part of the corrective action process associated with the control chart, usually in the out of the control action plans, OCAP, a very important part of the corrective action process associated with control chart usually is the out of control action plan. And OCAP is a flow chart or a text based description of the sequence of activities that must take place following the occurrence of an activated event. So, it is like a cause and it is just what are the sequence of things to be done so that you can get back to your normal state. That is what is out of control action plan. Okay. When the process goes out, so what is the action plan to be taken? The control action are widely used for the following reasons. The control charts are proven techniques for improving productivity, to reduce the defects, to prevent unnecessary process adjustments, to provide diagnostic information, and to provide information about the process capability. The sample size and sample frequency is another interesting topic which you have to note. In designing a control chart, we must specify both the sample size and the frequency of sampling. So, frequency of sampling is 1 in 50, 1 in 100. Sample size is within that 50 how many samples you have to take. We can evaluate the decision regarding the sample size and the sample frequency is thought the average run length of the control chart. So, if the process observation are uncorrelated, then for any steward control chart, ARL can be calculated as 1 by P. P is the probability that any point exceeds the control limit. This equation can be used to evaluate the performance of control chart. This is very, very important. If the process observation are uncorrelated, then for any Schwarzschild control art, the ARL can be calculated easily from ARL equal to 1 by P, where P is the probability of any point which crosses that limit. So, it is also occasionally convenient to express the performance of a control chart in terms of its average time to signal, ATS. So, ATS is nothing but ARL into H, where H is in hours. So, there are several phases, phase 1 and phase 2 of control chart application. The standard control chart usage involves phase 1 as well as phase 2 application with two different and distinct objectives. In phase 1, a set of process data is gathered and analyzed all at once in a retrospective analysis. Okay. So, it is done. So, gathering and analysis is done in a all at once in a retrospective analysis. So, next the control chart in phase 1 primarily assist operating persons in bringing the process into a state of statistical control. So, it is gathering and analysis of the data is done in phase 1. In phase 2, we begins after we have cleaned a set of process data gathered under stable conditions and representative of in control process performance. In phase 2, we use control charts to monitor the process by comparing the sample statistics for each successive samples. So, application of statistical process control and quality improvement tools in transactional and service business. The flow chart, process operation process chart and value stream mapping are particularly useful in developing process definition and process understanding. A flow chart is what? A simple way of a simple logical way of representing a matter or a protocol in a pictorial manner, in a chronological sequence, and a pictorial manner is the activity of a flow chart. Flow chart or a process map can be constructed in sufficient detail to identify value added versus non value added work activities which is done. So, this is the statistical base of control chart, where we follow a flow chart: start, process, D stands for delay, process is going on, there is a decision which is taken and then it goes. So, when we talk about quality control and improvement, statistical process control, the control charts are for variables and control charts for attributes are available. When the variables are measurable, it is called as we use control chart for variables. When the control charts for attributes, we always use with respect to this is whether the yes no factor, something like if the product is working or not working, something like that. So, are used to monitor characteristics that have discrete values and can be counted. For example, a cell phone working, not working, 1 defective, something like that. Example, percentage defective of number of defects on a mobile phone, number of broken eggs in a box, etc., etc. So, statistical process control, if you put it in a flow chart, you can have variable, you can have attributes. Variable, you have a sample size n equal to 1, you can have this, n equal to 2 to n equal to 10, you have x bar chart, n which is always greater than 10, we will have S bar chart, R bar chart, S bar chart. So, this is n equal to 1, you do this, n is between 2 to 10, you do this R bar chart, and if it is greater than 10, you always go for S bar chart. When you try to do attributes, it is single attribute, multiple attributes. In single attribute, if it says yes, it is an NP chart. If it is no, it is a P chart. The sample size constant, if it says multiple, if it says yes, it is a C chart. If it is no, we use it as a U chart. This is very, very important, sir. Very important. So, here are some of the formulas which are given. So, we are trying to figure out the upper critical and the lower critical value for X bar, upper critical and lower critical for R. So, all those things. You can expect a problem I can give you a set of data and then ask you to draw a control chart, or ask you to find out some value from the control chart, or ask you to try to figure out what is the lower critical limit, upper critical limit, etc., etc. So, I have dealt it X bar chart and R bar chart. X bar chart and R bar chart are here, X bar and R bar, 2 to 10 and greater than 10. So, the R bar chart represents a variety in the data, and if the variety is to be greater than, there is no need to look at the X control chart. The chart is out of control, then we have to go for this combination. So, this is an R chart. So, you can see the range, R bar chart is range is given. So, you see the upper critical, lower critical, this is the average. So, P chart and C chart, these are all for percentage of leaking cowling tubes in a box of 48, percentage of broken eggs in a carton. So, these are all P chart. Number of flaws or strains in a carpet, sample cut from a production run. So, that is a C chart. Number of complaints per customer at a hotel. So, if you go back, what is the C chart, U chart, right. So, the attribute charts, how are the formulas done? So, these are the formulas which are used to find out for C chart, and these are the formula which C chart. So, now this point is gone out of the critical limits. So, before it goes to this point, we are supposed to look back into the process and understand and then pull it back so that it comes back to normal. So, here what they have done is they have pulled back the process, reset the process. Same way for P chart, this is the upper critical limit, lower critical limit. This is how they try to calculate the sigma. So, the CL control limits can be found out by this formula. P type, again the same, pull out is done and then it is come. The control chart for non-conformability, non-conformities. So, that is defects, non-conformities are defects. A non-conforming item is a unit of product that does not satisfy one or more of the specifications of the product. So, that is non-conformance. People always say, please submit a non-conformance report. Non-conformance report means I have given you a spec, you have produced something, when I measured it, these are the parameters which did not stick on, or which was not seen in your part. So, that is non-conformance. Each specific point at which the specification is not satisfied results in a defect or a non-conformity point. In fact, you have a shaft, and here are some points where the conformation is not happening. So, this also can be represented in a figure. If you go back to the 7 tools, defect concentration diagram is that. So, here what we do is we draw the diagram and we try to put in the diagram how many failures have happened in that particular feature, or happened, or whatever has happened or will happen at that particular feature, and then you try to put the numbers. So, just by looking at the figures, I can easily find out where exactly the fault is. So, consequently, a non-conforming item will contain at least one non-conformability. As an example, suppose we are manufacturing a personal computer, each unit could have one or more very minor flaws in the cabinet finish. Since these flaws do not seriously affect the unit's functioning operation, it would be classified as conforming. Non-conforming if it does not meet the specification. It is possible to develop a control chart for either the total number of non-conformity in a unit, or try to take an average. So, further analysis of non-conformities, defects or non-conformity data are always more informative than fractional non-conforming because they will usually be several different types of non-conformability. By analyzing the non-conformability by type, we can often gain considerable insight about the defect. So, then we will go to the OCAP chart, out of control action plan chart. We revise the process, refer it along with the cause and effect diagram and come out with a solution. So, it is used by a chart called as U chart. So, the U chart is nothing but x divided by n, where x is the total non-conformity in a sample and n is the inspection in a sample of n inspection. So, n unit inspection, this is n is number of samples you have done and x is the total non-conformability in a sample. So, you can also have a UCL and LCL for the same and try to do a chart within that. So, currently here it has gone out of control. So, now from here what we do is we try to pull it back, reset the process and try to have better control. So, the choice between attributes and variable control charts, this is very important. The attribute control chart have the advantage that several quality characteristics can be considered jointly and the unit classified as non-conforming if it fails to meet the requirements. So, when you talk about variables, length, height, dimension, whatever it is, that is variables which can be measured. Attributes are yes and no, go, no go. So, here there can be so many reasons for it to become no go, or so many no go, so many things are not met, the conditions are not met, but still the product is working. So, it will get through. So, its attribute control chart is very interesting and it has to be chosen in such a way such that you try to get the exact information out of it. On the other hand, if several quality characteristics are treated as variables, then each one must be measured and either a separate or an R chart must be maintained on each or some multivariate control techniques that considering all the other characteristics must simultaneously be employed. So, we are trying to take R, that is okay, but when you try to take R, you might have several reasons, and if you can make all those reasons are variables, you measure it and then do it. Okay. So, this is the most simplest technique to do. The variable control chart in contrast provides more useful information of individual features. It does not talk about a feature, it talks about the dimension of a feature. Right. The specific the information about the process mean and the variability is obtained directly here. So, this all I have already dealt, so I do not want to go through line by line. So, guidelines for implementing the control chart: determine which process characteristics to be controlled. So, before even doing this, you should try to figure out those variables where it is considered as controllable variables must only be considered. If you try to take an atmosphere, which is a temperature at Kanpur in summer 45 degrees, a temperature at Kanpur during winter, temperature is around about 4 degrees. So, temperature is one thing which I cannot control. So, generally what happens, we try to take the characteristics of a feature or of a product, whatever it is, we try to take that and it has to be a controllable feature and there has to be a proper device to measure the deviation. Okay. Determine whether the chart should be implemented in the process. Choosing the proper type of the control chart is very important. Taking action to improve the process as a result of SPC is done. Then start collecting the data and analyzing the data through the software. The next important topic of discussion when it comes to the statistical methods for quality control is design of experiments. If I have to find out in a process what is the best optimum condition for making this product. So, then I will have to do multiple levels of experiments and then I will come out with the data saying that here is the best process parameters for making this particular product. So, here what is design of experiment is, I try to design my experiments in such a way such that I try to do lesser number of experiments, but talk more about the process and the levels of the process parameters is called as design for experiments. It is it is extremely helpful in discovering the key variables influencing the quality characteristics of interest in a process. It is an approach to systematically vary the controllable input factors in a process. The major type of design for experiments is factorial experiments. In this factorial experiments, the factors are varied together in such a way so that all combination factors are got. So, acceptance sampling. Acceptance sampling is connected with inspection and testing of a product. So, a lot of product is there, m units are sampled, 0 defects. If it is yes, lot is accepted. If it is no, 100 the lot is rejected, 100% inspected, non-conforming units are replaced. So, they do random pick. In the random pick, everything is through. 100 pieces they ran, 1000 pieces they random pick. All the 1000 pieces they check, if it is okay, it is okay, the lot is accepted. If the 1000 pieces they have some 2 pieces defective, then they do sort out has to be done and then you do. So, this is acceptance sampling is connected with the inspection and testing of a product. So, the quality test. So, what a student is asked to do is, you will try to note down an event which you do regularly. Okay. So, regularly, for example, you wake up or you leave to office, coming back home, okay, coming back home and then sleep. So, try to take the data for at least 1 week. You try to take the data, what time you wake up, what time you leave to office, what time you come back home, what time you sleep. 1 week you try to take the data. So, after you try to take the data, so then what will happen? You will have x1, so not 1 week, you take for 10 days. 1 week is too small, at least 10 days you take. So, you will have x1, x2, x3, x4, x5 going up to x10. So, you try to calculate the mean and then you also try to calculate the sigma for this data. So, then what happens? You try to plot a control chart saying that what is your upper critical level, what is your lower critical level, what is your mean and daily at what time you wake up, right. So, if you plot this, then you will try to see a naturally occurring event, how does this control chart help to improvise. So, when you try to look at this data, so suppose let us assume that you woke up late. Why did you wake up late? Because last night you slept late. Why did you sleep very late? Because I had dinner late. Why did you have dinner late? Because I came back home late. Why did you come back home? I had lot of work in the office. Why did you have work in the office? Because I was just whiling around or I was talking to people when in the peak hours and then I started working late in the evening. See, now you look at it, by looking at this graph, you can try to backtrace and then find out what all events happen, and how, by asking questions you now know who is the culprit, how have you to improvise your system so that you can try to meet the productivity. So, please try to do it for 4 different events for 10 days, plot it, try to calculate mean, then try to calculate sigma, then you decide mu plus or minus 2 sigma, mu plus or minus 3 sigma. So, now you can try to tell then how consistent is your process of waking up, sleeping, coming back home or leaving to the office. Thank you very much.